we want to simplify I to the power of this large number here. So in this case, we need to know a few basics here. Anybody know what I is equal to? Talked about this in the previous sessions. Anybody remember what I is equal to? That would be square root of what? Anybody with the microphone, you can just grab a mic and tell me. Some of you are typing, not 1, close. Some of you are typing as a negative 1. Negative 1, yes.
Negative 1.
It would be negative 1. Very good. The square root of negative 1 would be equal to I. So everywhere we see a negative square of negative 1, we replace that with I. Okay. So knowing that, see if you can tell me what I squared would be equal to then. I squared would be square root of negative 1 times square root of negative 1, right? Because it's I times I. So that
Which would just equal negative 1.
Negative 1, yes. Because of the fact that radical A times radical A is equal to A. Very good. So if you want to remember any of these, that would be one of the ones that you can remember. I squared is equal to negative 1. Everywhere you see I squared, just replace it with negative 1. Because you're going to see this quite a bit in the calculations. I'm going to put a little star here so you can remember that. Now, I cubed then, I cubed would be I squared times I. Well, we already said I squared is equal to, I'm going to remember it every time, it's equal to negative 1. Negative 1 times I is equal to I. So this whole thing would be equal to minus I. So I cubed is the same as minus I. Now, I to the power 4, is the same as I squared times I squared. Now, I squared, it just says equal to negative 1. So each of these are equal to negative 1. So negative 1 times negative 1 is equal to 1. So this would be another one that you want to remember, handy one to remember. I to the power 4 would be equal to plus 1. So when we have I to the power of a large number or any number, would be either equal to plus or minus 1 or plus or minus I. That's what it means by simplify that. So in order to see what I to the power of this large number is here, so you have I to the power of 1, and this would be 12,225. What you can do is you can divide 4 into this large number. The reason I use 4 is because I to the power of 4 is equal to 1. Some people divide it into 2, but to avoid this negative number here, you can remember divide it into 4. I think 4 is easier. So if I divide 4 into that, okay, you can use your calculator if you want to even. So you can divide 4 into that number. Can somebody tell me what do I get if I divide 4? I get some decimal numbers, right? Anyone? If I divide 4 into 12,000.
Yeah, you get 3,056.25.
Right, exactly. So you get 3,000. Let me see if that's the same problem that I had earlier. 1225. Okay. That's fine. So that would give me 3,000 So 3056 times 4, that gives me 12,224. So what would be the remainder, anyone? 1, right? The remainder would be equal to 1. So what that means is 4 times, that means 4 times this number, 3056, plus 1, the remainder, would give me 12,225. So if I want to write that as I to the power of 4, then to the power of 3056 times, I need to multiply that by another I to the power of 1. Okay, make sure we follow this. Because 4 times 3056, see, 4 times 3056, and then here you add the exponents. Remember, when you multiply, you add the exponents, plus 1, give you this number here. So everything is here. The only thing I'm doing here is I want to make sure that I get as many I to the power of 4 from this, because I to the power of 4 is equal to 1. So I would have 1 to the power, doesn't matter what the exponents have here, still going to be equal to 1. So you end up getting just I. So you really look at the remainder. If the remainder is equal to 1, this whole thing would be simplified to I. So this would be just I. If the remainder turns out to be 2, then this whole thing would be equal to I to the power of 2, which would be the same as minus 1. If the remainder turns out to be equal to 3, this whole thing would be equal to I to the power of 3, which would turns out to be equal to minus I. Remember, so you would simplify this to either plus or minus I or plus or minus 1. Okay, so it looks like we still have some problem here. Can you repeat the question again? You had some question earlier before I stopped recording. Go ahead. What part is confusing?
Why is to the power of 4 simpler than if you were just to go to the power of 5?
Sure. Okay, the reason is because, first of all, I to the power of 5 is not going to give me a plus or minus 1. Only in this case, I to the power of 4 would help me with this calculation. Because what is I to the power of 5 anyway? You pick 5, I to the power of 5. I to the power of 5 would be I to the power of 4 times I. Do you agree with that? Right?
Yeah.
So I to the power of 4 we established is equal to 1. So 1 times I. So I to the power of 5 is equal to I. So that's not going to help me to simplify this. Let me make a simpler example here. Let's make it I to the power of, let's say, 15. Let's make it a little smaller, right? So if I find how many I to the power of 4 I have within I to the power of 15, that helped me to simplify this. So let's do that. Let's divide 4 into 15. Go ahead and tell me, William, what do you get? When you do that, what would be the remainder?
3, remainder 3.
Yeah, so we get 3, would be 12. Great, very good. So I can write this as I to the power of 4 to the power of what? William, why don't you go ahead and finish this part for me? What goes in here, up here now? I to the power of 4 to the power of what?
I have literally no idea.
Okay, so see, I'm going to use a different color here. Because I'm going to use 3 here, and put 3 here. Because 3 times 4, see, 3 times 4 give me 12, right? And then the remainder here is 3. So I'm going to put another 3 here. Remember, a to the power of n to the power of m is equal to a to the power of n plus m. You add the exponents, right? So if I were going to multiply this, that would be I to the power of what? These two together would be 12, right? Plus 3. Does that make sense? Do you agree that we have I to the power of 15 here?
Yeah.
That's exactly what it is. 3 times 4 plus 3. That's a remainder. This is a remainder. This is a remainder. Okay? So what's going to happen here when you write it like this is because I know I to the power of 4 already is equal to 1. So everywhere I see I to the power of 4, I'm going to replace it with 1. So it would be 1 to the power of 3. It doesn't matter what number here is. Anything to power 1 to the power of any number would be equal to just simply 1. So here would be just 1. 1 times I cubed. So the answer would be I cubed, right? But what is I cubed? I cubed is I squared times I. I squared we already established is equal to minus 1. So this would be minus 1 times I. So this whole thing would be equal to minus I. So this is equal to minus I. So if I change that 15 to 16, let's see what happens if I do that. I to the power of 16. Okay? So let's do I to the power of 16. I to the power of 16. Okay. Wait, I want you to work with me here. So if I use this method here, so what do I have to divide 16 into? Four, right? So we're going to divide 4 into that, right? So what do we get here?
4.
4. Which is what? The remainder is what?
0.
0. The remainder is 0 here. Okay? So this turns out to be I to the power of 4 to the power of 4. There's no remainder, so I don't have to add anything here. So we know, again, I to the power of 4 is equal to 1. So it would be 1 to the power of 4, which is equal to 1. So I to the power of 16 would be equal to 1. Okay? How about we use I to the power of 17? Let's go to I to the power of 17. I to the power of 17. If I use the same method here, if I divide 4 into that, what do I get?
4 remainder 1.
Right, 4. That would be 16. The remainder would be equal to 1. So can you help me out how to write this now? You write this I to the power of what?
I to the power of 4 times I.
Okay, so it would be I to the power of 4 to the power of 4 again, right? Okay. That would be 16, and then we need another I here, right? So this would be 1 to the power of 4, which is equal to just simply 1 times I. So this whole thing would be equal to I. Would you agree with that?
Yes.
Okay. We'll do I to the power of 18, I to the power of 18. Divide 4 into that. What do we get?
4 with the remainder of 2.
4, remainder is 2. So I can write this as I to the power of 4. See, I want to know how many I to the power of 4 I have within that huge number there. So that would be 4 again, 16. So I need 2 more i's to get it equal to 18. So this would be 1 again. So the whole thing would be equal to what? Just I squared. What's I squared? -1. Okay, so let's go back and see if we can see a pattern here. So I to the power of 18 turns out to be -1. I to the power of 17 turns out to be I. Because if the remainder turns out to be 2, looks like if the remainder is equal to 2, because we don't care about this part here, because I to the power of 4 to the power of anything would be equal to 1. The remainder is important here. So if the remainder turns out to be 2, so this whole thing would be equal to I to the power of 2, which is equal to -1. If the remainder turns out to be equal to 1, this whole thing would be equal to I, so the whole thing would be equal to I. If the remainder turns out to be 0, so that would be just 0. There's no remainder there. I to the power of would be 1 to the power of 4, which is equal to 1. And if I had I to the power of 15, right? So in this case, I get 3 times 4 is equal to 15. The remainder is 3. So the remainder is 3. The whole thing would be equal to 3. I to the power of 3, which is equal to -I. And then when we had this huge number here, we did the same exact thing. We divided 4 into that. The remainder is important. The whole thing turned out to be I to the power of 1. We don't care what this number is, this huge number is, because I to the power of 4 is equal to 1, 1 to the power of anything is equal to 1. So the whole thing turns out to be I to the power of the remainder, which is I. Do you see that a little bit better now?
So basically, once you find out what the remainder is, you can pretty much find out whether it's an I, 1, or the opposite of, right?
Yes. Yes, basically, yeah. The remainder would tell us what the whole thing would simplify to. But you need to write this whole thing like I showed you, so you can show that how you simplify this.